Hello everyone, my name is Tony. Today I will introduce the security consideration for the 5G area. So first, I will simply introduce the background of 5G. Okay, one is why is 5G different? I think there are two big concepts. One is 5G includes the SDN, the software-defined networking, to separate the user plan and the data plan. And another is network function virtualizations, which means we virtualize the network function from the hardware to software. That means from now we can install or run the network function by normal PC. We don't need the specific hardware anymore to reduce the cost for the 5G network. And another important concept in 5G network is network slicing, which means we group each users according to their services. There are three big concepts of the services. One is EMBB, the enhancement mobile broadband, with the throughput speeds that could eventually be as much as 20 Gbps when millimeter wave frequency are available. Another is URLC, the ultra reliability low latency communication for the service which needs 1 millisecond delay and reliability higher to the 99.999%. And the final is MMTC, the massive machine type communications, provides the connections to large numbers of devices that intermittently transmit small amount of traffic. Due to the several services for different users, that's why we need the slicing to separate them to the different scenarios to avoid the conclusion and other bad effect to the throughput or transmission speed. And another important concept is the distributed architecture. 5G will have a much more distributed architecture than previously wireless network, because some reasons, and then I will talk about why the 5G will need more distributed architecture. One reason is because the densification of the radio. The need for increased coverage and better experience per devices will maintain an increased number of radios. And to increase the centralized RAN development with a splitted CU and DU architecture. So we need to more distributed antennas to help us to achieve this network architecture, and another is introductions of edge compute. The distributed of compute power closer to edge to provide better quality of experience and fulfill new use cases, and the introduction of new application in addition to standard voice and broadband data, and the expected bandwidth increases with open up of additional spectrum in the MM wave band. Also, the final reason is development of deterministic behavior URLZ services to handle low latency application and guarantee their upper bound latency limited with a fixed jitter and a low peak error loss rate. The distributed architecture is very useful to help us to achieve this goal. And then I will introduce the threats, vulnerability, and the attacks. In this part, we will separate into two network architecture. First is NSA, prefer 5G standalone. NSA means we use the previous generation network element to help us to achieve the 5G network. So we can see in this architecture we have 5G G0 B means the 5G antenna, and the 4G E0 B, the 4G antenna. So with these two generation antenna connect to the core network, we can achieve the preferred 5G network. And due to this network architecture, some attack we might face. One is the 2G and 3G downgrade attack, which means the attacker will downgrade the downgrade attacks allows for advances to force an LT connects UE to 2G or 3G, which has significantly less security controls, because previous generation network architecture might not security. So then the adversaries can use these vulnerabilities to attack users. And then the IMSI tracking, which very close to the privacy. Adversaries could check the IMSI to determine if the users is useful to them, and adversaries can token some security from the users. Then is the man in the middle attacks, which means the customer's message and or communication flow could be intercepted in the middle between the UE and the servers. And final is LT roaming. LT roaming is heavily depends upon the SS7 and the diameter protocols. Both the diameter and the SS7 are vulnerable to eavesdropping, including voice calls, reading text message, and checking phones. So that's why the LT roaming is also the potential dangerous to the 5G NSA network. And then the 5G standalone, the SA, is the full 5G network. In this architecture, we don't use the 4G or 2G or previously generation network element anymore. We just use the 5G antenna and 5G core network. And also in this network, we might face some new risk or attack, and then I will start to introduce those risks. One is the service-based architecture, because we include the SDN and the NFV concept into 5G, which means we use the open source to design our network. And then we might face some potential risk because of the open source is open to everyone. So the code might not security to some adversary. So how to design a security network with the SDN and the NFV is an important concept to 5G. And then the supply chain, hardware and the software. The operators must require that the OEMs embrace a secure and reputable auditor. And also the man in the middle is still the risk to 5G standalone because of the user plan, integrator protection, and the SUPI, SUCI privacy. 3GPP has addressed this by removing the clear text IMSI and moving to a SUPI, SUCI solution to avoid high value customer is captured and checked by adversaries. But few instances where the customer could be checked if the SUPI is sent over the air. Those cases are unassociated devices, and a UE with a legacy SIM that has not been provisioned with 5G public key via the OTA update. And third is customers bring their own devices into an operator's network with SIMs that have not been updated. Okay, and final is the 5G NSA and the SA roaming. Like the LT roaming, the 5G roaming is still have some potential risk because of some roaming still use the SS7 or diameter protocol, so which with the potential risk to users. And then I will introduce the security considerations and its impact on 5G. And in this part, I will just simply introduce the cloud network architecture and the security. The cloud native MEC, which means the multiple access edge computing. will deliver the 5G services from a distributed cloud, enabling new mobile use cases for the customer's business and the public service. This enhancement of security protection, like each container performs dedicated functions, enhancing behavior profile and anomaly detection, and also the decompression software providers, and the segmentation with network slicing, separated traffic, and isolated compute resource, which help MEC to secure the network. Okay, so finals. Although MEC provides a new concept to protect the network, it brings a new security risk. One is the uses of open source code, more interface, and the new APIs introduce new threat vectors. And then the shared hardware resource can result in cross consumption, and the containers requires elevated privilege can cause security risk to both host and as well as other tenant containers. Dependency upon central authentication introduce a new threat vector, and the high data volume and the session increases risk from the attack. Finally, the application running in the microservice architecture are as vulnerable to the same attacks as the traditional application. So although we have a new concept and network elements, we still have some potential risk we need to face, and how to solve this risk and to protect our network is the future 5G network operators need to consider. Thank you.